In this video, we are going to focus on rational exponents or fractional exponents, where fraction exponent is a fraction. So definition of a to the power 1 over n. If n is a positive integer other than 1 and nth root of a is a real number, then we can express a to the power 1 over n as a radical. So the denominator n becomes the index. For example, if you have a to the power 1 half, that can be written as square root of a. A to the power 1/3 is same thing as cube root of a. A to the power 1/5 is same thing as fifth root of a, as long as fifth root of a is a real number. Okay, a to the power 1/4 would be fourth root of a. Okay, so we can express the exponential form into the radical form. So exponential form where we have written the exponent as a fraction, radical form where we use the fourth root. Some examples: use the radical notation to write each of the following and simplify if possible. 4 to the power 1/2 is same thing as square root of 4, which is equal to 2x. X to the power 1/4 is same thing as fourth root of x. I can pull out an x squared. 27 to the power 1/3 is same thing as cube root of 23, which is same thing as 3. Because think about, you can write 27 as 3 to the third power, and if you divide 3 with the 3 index in the exponent, then that turns out to be equal to 3. A 3 comes out. You have 3 3's inside. 81x to the 8th raised to the power 1/4. Now, because of the parentheses, this entire thing is in the fourth root. 81x to the 8th power. So we have 81 to the power 1/4 x to the 8 times power 1/4. Now 81, fourth root of 81 is what number multiplied with itself 4 times will give me 8 times 1/4 is going to be 2 here. What number multiplied with itself 4 times gives me 81? That is 3. I did not mean to touch the eraser here. That is equal to 3. And 8 times 1/4 is 2. 3x squared is what comes out. 5y to the power 1/3. 5 is not raised to the power 1/3. It's important to realize. And I'm going to write it as 5 times cube root of y. So my goal was to write in the radical notation and then simplify if possible. It's not possible to simplify it any further. Example number 5. But I'll just stop right there. So it's 5 times cube root of y. Negative 9 to the power 1/2. Now the negative is not inside the radical. It's negative 1 times 9 to the power 1/2. Because we do know if there was a parenthesis around negative 9, then the entire thing was in a square root. But right now we don't have parentheses around. So this turns out to be negative 1 times square root of 9, which is negative 1 times 3, and that's equal to negative 3. Negative 27 cube root, which is negative 3, because negative 3 times negative 3 times negative 3 is going to be not a real number. Next we have negative 9 inside the parentheses. That means the entire thing is going to go in the radical. Now, is there a number that multiplied with itself will give me negative 9? Not really, because 3 times 3 gives me positive 9. Negative 3 times negative 3 also gives me positive 9. So no, there is no real number multiplied with itself that gives me negative 9. So this one is going to be not a real number. We have talked about complex numbers. When you have a negative inside an even root, your solution is not a real number. It is an imaginary number, a complex number. Okay, let's try some more problems. 16 to the power 1/2, that would be square root of 16, which is going to be 4. Negative 8 cube root. Well, negative inside a cube root is not a problem. Negative inside an even root is a problem. We have discussed this before, especially when we talked about domain of radical functions in the very first section. So that's going to be negative 3. This negative is not going to be inside the radical, because it's like negative 1 times 81 to the power 1/2, which is negative 1 times square root of 81. That's negative 9. And now we have the negative going inside the radical because of the parentheses around, and that would be not a real number. Or if you want, you can call it 9i, because we've talked about it. We can break it into square root of negative 1 and square root of 81, which is I times 9, and that's 9i. 100 to the power 1/2 is square root of 100, which is going to be 10. Review of laws of exponents. So, seventh grade algebra, we've talked about these rules of exponents. So, a quick review of them. Zero exponent rule. Anything raised to the zero power is always equal to 1. For example, 7 to the 0 power is 1. X to the 0 power is 1. 7x to the 0 power, we're not raising the 7 to the 0th power. There's no parentheses around. It's like 7 times x to the 0 power, which will be 7 times 1, which is equal to 7. If I have 7x to the 0 power, that is going to equal 1. Okay, so anything to the 0 power is equal to 1. Negative exponent rule. So if you have a negative exponent, you can always bring it in the denominator and make it positive. Same thing applies if you have a negative exponent in the denominator. You can take it to the numerator and make it positive. Okay. I want to quickly check if yeah, it's coming up, so I'll just wait for that. So for example, how does that rule work out? Why is negative exponent, why can we bring it to the denominator and make it positive? Let's think about powers of 2. 2 to the third power, 2 to the second power, 2 to the 0 power, 2 to the first power, negative 1 power, negative 2 power. 2 to the third power is 8, 2 to the second power is 4, 2 to the first power is 2. You can see as my exponent is going down, I'm dividing each time with the base. The base is 2 here. Now 2 divided by 2 is 1, so that verifies the first rule we talked about. Again, divide by 2, again, divide by 2. So that's just to verify the rule of negative exponents. So if you have 2 to the negative second power, you can do 1 over 2 to the 2 power, which is 1/4. Product rule. So if you're multiplying, the bases are same, exponents are different, we can add the exponents. Okay, bases are same, there's multiplication in the middle, we can add the exponents. 2 to the third power times 2 to the fourth power is going to be 2 to the 3 plus 4, which is 2 to the seventh power. Next, we have the quotient rule, a to the m over a to the n, which turns out to be a to the power m minus n, and that's 1 over a to the power n minus m. So if you have a quotient, same base in the numerator, same base in the denominator, different exponents, we can subtract the exponents, okay? 3 to the 6th over 3 to the second power, we can subtract the exponents. That would be 3 to the fourth power, which is 81. Power rule. So if you have an exponent inside and an exponent outside of the parentheses, those two exponents will multiply. So it would become a to the power mn. Here's an example. 5 to the second power raised to the third power. 2 and 3 will multiply and become 5 to the sixth power. Product to power rule. So here we have a product inside and exponent outside. Every single base inside will get the outer exponent. So 3 times 7 to the third power will be 3 to the third power, 7 to the third power, which is going to be, I'm not going to simplify that. Just leave it at this point, but you can go ahead and use a calculator, multiply, and figure out what that is going to equal. Another example, if we have 7x to the second to the third power, remember every single base inside, the outer exponent will multiply with the inner exponent. So 7 times 1, 7 raised to the power 1 times 3, x raised to the power 2 times 3. So 7 to the third power times x to the sixth power, okay? The outer exponent multiplies with the inner exponents. And if you don't see an inner exponent, there is a hidden one, like I used for the 7. Quotient to power rule. So if you have a quotient and a power of the quotient, every single base gets that power. Every single base inside the quotient gets the exponent. Here, to do the 2 over 3 raised to the fourth power, I can express it as 2 to the fourth power divided by 3 to the fourth power, and then we can simplify from there. Quotient to a negative power. So if you have a quotient to a negative exponent, you can flip the fraction and make the exponent positive. For example, 3/5 to the negative third, we can write it as 5/3 to the third power, okay? We can express it as 5/3 to the positive exponent. Understanding a to the power m over n. Remember that any rational exponent can be written as a radical, that the numerator becomes the exponent and denominator becomes the index. So far we talked about a to the power 1 over n, and we said it's equal to nth root of a. Now we're talking about a to the power m over n. Both m and n are, integers. So we can have integer m, integer n, and we can still express it as a radical. So here, a to the power m over n, we can express it in two different ways. Let's check it out. A to the power m over n. Keep in mind the numerator of fraction will become your exponent. Denominator of fraction will become your index. So a to the power m over n. And maybe use different colors, that might help. Okay, denominator is going to become the index, numerator is going to become the exponent. Okay, so here we have a. This can be expressed in two different ways. A to the power m nth root, or we can also express it as we can also express it as a to nth root of a raised to the power m. So both ways it's correct. Remember that any rational exponent can be written as a radical. So we are going to see some examples of this. Both ways it's correct, and usually this way is easier to simplify. Okay, doing the nth root of a smaller number and then raising to an exponent is easier. Is it correct to rewrite cube root of 5 to the second power as 5 to the 2/3? Yes. Is it correct to write fourth root of 7 to the third power as 7 to the 3/4? Yes. Evaluate 9 to the power 3/2. So we can express it as 9 to the power second cube root, or we can say cube root of, change it. The denominator becomes 9 to the third power, or square root of 9 to the third power. So both ways it's correct. Either we can raise the exponent outside or inside the radical. Both ways it's correct. Usually the second way is easier. So I'm going to go ahead and simplify it. Square root of 9 is 3. 3 to the third power is 27. Okay. Evaluate 125 to the power 2/3. So 125 cube root raised to the second power. Cube root of 125 is 5, because 5 times 5 times 5 is 125. 5 raised to the second power is 25. Now, next one, it's a negative, but it's not going to go inside the base, because if I had a parentheses there, that was the danger for me. But there's no parentheses, so negative is not going to go inside the radical. So it is square root of 36 raised to the third power, which is negative 1, times square root of 36 is 6 raised to the third power, which is negative whatever 6 raised to the third power is. Next, we have a cube root. Think about the 3 in the denominator. This is going to become your index, and it's a cube root. It's okay to have a negative inside the cube root, okay? That's totally fine. What's cube root of negative 27? Cube root of negative 27 is negative 3. Negative 3 to the fourth power is positive 81. Okay, couple more examples. Evaluate negative 25 to the power 5 over 2. So it's negative 25 square root to the fifth power. Well, there's a trouble, because we have a square root and a negative inside. That's going to be not a real number. Next example, the negative 1 is just sitting in the front, so it's not an issue. So it's negative 1 times square root of 25 is 5 to the fifth power. Whatever 5 to the fifth power is, we will simplify that using a calculator. Next, we have a negative base and a negative exponent. Remember, we can write it with the positive exponent. So we can write it as 1 over negative 27 to the power 2/3. We can flip the fraction and make our exponent positive. We can bring it in the denominator, make the exponent positive. That's what I just did. 1 over cube root of negative 27 raised to the second power. So it's 1 over negative 3 to the second power, which is 1 over 9. Okay. Rewrite the following radical expression as a rational expression. So it would be x to the power 3/5. Remember, denominator becomes the index, exponent is the numerator. Rewrite the following expression with the rational exponent. So 2 times a to the power 2/3. Okay, here's a few try me problems. Go ahead and give them a try and come back and check with me. Okay, -9 So it's negative 9 square root to the third power, not a real number. Negative 1 times 9 to the power 3 halves, negative 1 times square root of 9 to the third power, which is negative 1 times square root of 9 is 3 to the negative 27, 4 to the power 3 halves, which is square root of 4 to the third power. 2 to the third power is 8, and negative 32, fifth root to the second power. Fifth root of negative 32 is negative 2. Negative 2 to the second power is positive 4. We'll see more examples on the rational exponents in the next video.